Let me make sure the audio is, yeah, audio is working. Yeah. Hello, hello. All right, good stuff. And we are back. Let's go ahead and finish this up. So in that last example, we actually ended off, we found mean, median, mode, midpoint, and we ended off looking at a frequency table as kind of our way of assessing, the shape of the distribution, right? So we could tell which one of those measures of central tendency was kind of the best play, right? The best measure of the middle. So we kind of ended off on a frequency table. So I want to start again with some data, but this time I'm going to start with a frequency table. So I want to continue on that idea of let's look at a frequency table. So now in this example that we're going to look at, instead of being given the data, instead of being given the raw data, what we're being given is the frequency table. So basically there was some raw data, but you don't have access to that. You have the frequency table that somebody created off of that data, right? So what if we just have that? What can we do as far as finding measures of central tendency? So give me a second. So I want to get the data. Actually, this one might be good for me to turn on the projector. Not sure. Second. Do. Yeah, I think this one, let me go ahead and turn on. Let me turn on the projector and do the whole thing because it'll just take me a decent bit of time to reproduce it on the board. So let's do that. And so let's also move the camera. Oh, you know what? Actually, they disconnected this from the desktop computer. I don't. Oh no, that's how we fix that. All right, there we go. Sweet. All right, so let me bring this down and let's look at this particular bit of data. So I actually want to look at, it's going to be number 7. Our exercises for 3.1 here. And something like that. All right. So like I said, you don't have the luxury of having the original data, but you do have this. So this is the percentage of college educated population over 25. So below are the percentages of the population over 25 years of age who have completed 4 years of college or more for the 50 states in the District of Columbia. So I was talking a little bit last time. This actually works really well with my random conversation that I insert into these lectures. So we were talking about, the U.S. being one of the few countries that has states, right? That has these separate sort of political entities, not just counties, but that have a balance of power in running things with the federal government. So these are the 50 states. So for the 50 states in the District of Columbia, so basically 51. This is the frequency table for the percentage of population. It says over 25 years of age, so 26 or older, who completed 4 years of college or more. So that means they have a bachelor's or they've done more than that, right? So they've done work towards a master's or they've done work towards a PhD. So if you think about sort of your life growing up and kind of the environment, when I say environment, I mean like, when you think about people's expectations, the both things you hear on TV, things you hear with your family, on the block, in the community. Education is a huge drive. So a little bit like I was talking about on that last lecture, there's a good reason for it. I mean, the data, and I don't even mean just data. I don't even mean just numbers. The practical results show it. People who really basically haul ass on education, and work towards that. And when I say education, I include I include technical jobs. So I'm including plumbing, electrician, et cetera. Um, they not only they on average make a lot more money, have a lot more, are a lot more secure for their families, like so they can make a family, they can settle a house a lot easier, but their kids in the future are a lot more secure because if you grow up with a bunch with with family members that took that, so it's not just that they went to college, right? It's not just that they've got a degree, but obviously it was a big deal to them, made it important. So if you grow up in a family where that's the culture, it's important to do this because it's going to get things better for you, then doesn't mean everybody in the family is gonna do that, but more people are going to do that, right? And so and then again, in general, their salaries, their ability to kind of not just have enough to live, but have extra, that's going to be better, et cetera. So I start this by saying it, again, when they say education makes things better, and I say this despite I understand that a lot of people are getting out into markets looking for jobs, got a degree, looking for a job, and some of those jobs aren't there anymore. But even with that, so what I'm saying, even with that, even with those data points, when they say education makes things better, that is a fact, not of data, but of practical real life. I know so many people. I grew up really well. I'll say I grew up poor. I won't say really poor. I wasn't. I mean, there are a lot of people in the world that were a lot poorer, right? But I grew up poor. I'm the oldest of five kids. My dad probably made on average $27,000 a year my whole life growing up. We got half our stuff from the thrift store. We got half our stuff from Goodwill. We had food given to us. And my parents worked their asses off. So it wasn't even like, I mean, they worked their asses off and we still needed food and we still needed to buy stuff from Goodwill half the time, right? Um, so, what do you call it? In my own experience, I know this to be true. The people who focused on education are way better off right now. So I say all that. That's just a practical truth of everyday life. But then the interesting thing is again, so you hear all that, but this is the actual, so for the 50 states and District of Columbia, this is the actual percentages of basically what we're saying is adults after college, right? So they're assuming that you know, takes you 4 years or more to get a degree, right? So maybe you start at 18, but maybe you start a couple of years later. So for this survey, they looked at people that were over 25, so 26. So they're giving you about 7 years, right, to do at least a bachelor's, if not more. So they looked at people that are 26 and older, adults 26 and older, and looked at the percentages that had a bachelor's or more. And so again, with all that, you would think the percentages would be huge. And if you take a look at this, it's surprising, but it's true. The percentages are not that huge. So there was 3 states where percentage of people 26 or older that have a bachelor's or higher was only 15.2 to 19.6%. 15 states where it was 19.7 to 24.1%. 19 states where it was 24.2 to 28.6%. But then only 6 states where it was somewhere between basically 28 to 33%. 7 states where it was 33 to 37%, no states up to 42, and then one state where it's 42 to 46%. So if you look at this, the majority, 34 out of the 51 states and District of Columbia, the percentage of adults, basically the percentage of adults that have a bachelor's degree or higher is only really about 25%, roughly. And that's the truth. For all the push for education and how we know it improves people's lives, not only do not only obviously people have choice, but people also have lives and things happen. Again, I grew up poor. Um, I know a ton of people with success stories. I also know a ton of people who couldn't get up out of the fact that you just kind of have to keep making money, right? To make the bills, and you have to keep making money to make the bills, and that takes your whole life. That takes all your time. That takes your whole week. That takes your whole life. Makes it really hard to go to college. Makes it really hard to get the degree you need to have that chance at a job that gets you up and out of that, gets you above water, basically, so that you're not just making enough money to make that week go, to make that rent go, and then do the same thing over and over again, right? And you're working your ass off, so yeah, I'd say that I think there's a general perception that poor people are lazy, and it's quite the opposite, at least in my experience. Most poor people work harder than most other people that you're going to see. And it's not that other people don't work hard. It's just poor people work their asses off. But if you're only making enough money to get by, kind of can't get up, right? So it is hard. It is hard to get the time and space to get that education. Which is why honestly, so I really don't do this to make a plug for, believe me, Alamo colleges or anything like that. But stuff like Alamo Promise that Alamo Colleges does, where you're getting, if you graduate from the high schools here, you get a free education essentially for 2 years. That's the reason they're trying to do that. They know these stats and they know how hard it is to be poor and to get up. And so what they're trying to do is say, hey, like, we have, let's use the money that we're getting for tuition and the money that we have from our backers and the money we get from our partners to give you that chance, to give you that air, right? Because if you have to work while you're going to college, it's going to be really, really hard. So why don't we give you 2 years of college, as long as you put in the work and the time, but give you that free space so that you could actually do college and not just to work another week and just barely get by, right? So that's why stuff like Alamo Promise, Pell Grant, scholarships, that's why those things are important. Because it is just hard. If you're just getting by, you're using all your time and energy to just get by. What do you have left to get ahead? What do you have left to get ahead, right? So take advantage of those things. If somebody's going to help you out, please, for the love of Jesus, for the love of whoever you consider holy, please use those. Get ahead. Make it so that you're not just working to just barely scrape by. Again, I say that that's not a doubt. You are working your ass off. Please take some help. Anyways, so it is hard. And this has been honestly, this has probably been a pretty consistent statistic. I've seen this I've been teaching for 15 years in college. And I've seen this statistic. It's been roughly about the same for probably my 15 years of teaching in college, that only about 25% of adults end up getting a bachelor's or higher. So anyways, that was, but this is the data we have. So we don't have individual data points. We have this amalgamation of data points. We don't know, for these 15 states, we don't know what their actual percentages are between 19.7 and 24.1. We just know that for 15 states, their percentage of adults 20 over 25 that have a bachelor's or greater is somewhere between 19.7 and 24.1%. And we know that 19 states have a percentage between 24.2 and 28.6, but we don't know the actual numbers. So it's the first thing I want you to notice about if you're given data this way. This is actually a little problematic because we don't know the actual numbers. So when I say problematic, let's look at why this is problematic. Let's say that you want to calculate the mean, like we've been doing. And we know that the mean is you add up all of your data and you divide by how many there are. Now, again, they're not giving me the actual percentages for the 50 states plus the District of Columbia. So my first question to you guys is, can we add them all up? I didn't think about that. Could we add them all up? We can't. Definitely can't add these up. The frequencies are not the data. These are not the percentages from the states, right? This is just telling you how many states fit these classes. But we don't actually have the data. We don't have 50 states plus one District of Columbia, a box of data where we can add them up and divide them like we've been doing. But they're still going to ask you to find the mean of this data. And so again, the first thing is they ask you to find the mean of the data and you're like, hey dude, I can't do it. I don't got the numbers. means I gotta add them all up and divide by how many there are, but I don't know what the numbers are. So then the next question is, how could we get, so when we get the mean, so what we're gonna look at is they say find the mean in modal class of this data. We're gonna look at the mean. When you find the mean on this, we're gonna get we're actually not gonna get the true mean, but an approximation to the mean. But we can get a good approximation to the mean. And so let's think about maybe how we could do that, because again, the fundamental issue here is I don't know what these three numbers are between 15.2 and 19.6, and I don't know what these 15 numbers are between 19.7 and 24.1. So how could we get a good approximation to the mean? And what it ends up being, and so this goes back to one of the things we learned on pretty much, I think, the first video that I made for you guys. So when we were making these frequency tables, we would come up with these classes, right? And you'd write down the classes. And then one of the things that they asked you to do in that homework that really, they just asked you to do it. It didn't have anything to do with anything else, but they asked you to find the midpoint of these classes. So they asked you to find literally sort of the number in the middle of the two numbers that you see at the beginning and the end of your class. So they asked you to find the midpoint of each of these classes, and you just did that as homework, and you did it and you brushed it off because there was no use for it, right? We didn't really do anything with it. We just did the math. Now we have a use for it, because these three numbers that are between 15.2 and 19.6, I don't know what those three numbers are, but a good approximation is I could say all three of those numbers are the midpoints of that class. And I know that they probably aren't exactly the midpoint, but they're probably pretty close to the midpoint. And so so these three numbers, I can pretend that they are the midpoint between 15.2 and 19.6. And then these 15 numbers, I can pretend that they are the midpoint between 19.7 and 24.1. Now, again, they definitely likely aren't, the numbers aren't actually the midpoint, but these 15 numbers are going to be numbers that are either less than the midpoint or more or greater than the midpoint, but probably pretty close to the midpoint. So we're going to use the midpoint as sort of our faux, like our, I'm thinking of a different term, but our sort of approximation of what these numbers are. We're going to pretend that all 15 of these numbers are whatever the midpoint is here. And again, while they aren't, when you add them up, when you add up all the real numbers, you're going to get something pretty close to what you get up when you add 15 of these midpoints together. It's going to be pretty darn close. And then I'm going to pretend that I have 19. These 19 numbers are all the midpoint, because again, when I add up all 19 of the numbers that fit this class, they're not going to add up to exactly 19 of the midpoints, but they're going to be pretty close. So we're going to use the midpoint proxy. That's the word I'm looking for. We're going to use the midpoint as a proxy for each of these numbers. So that means to get my mean, like we did on the first homework, I'm going to need to figure out the midpoints of each of these classes so that I can treat it like I have 3 of that midpoint and 15 of that midpoint and 19 of that. So I can basically say my data is actually 3 of this number and 15 of this number and 19 of this number. And once we have that, then we can find the mean, because then we can actually kind of add them up, right? All right, so that's the first thing I need you to do then. So just like you did on the first homework and we did on the first video, I need you to find the midpoints of each of these classes. So I'll have you do that first, and then we'll come and figure out the mean. So go ahead and pause on your side. I'll pause on my side. Go ahead and figure out the midpoints for each of these classes. All right. Good. So what did you get for the midpoints? So remember midpoints, we were actually talking about this on the last 2 videos too. So again, this is kind of really in meta on point. To find the midpoint, you're gonna take the 2 numbers you want the middle of and you add them up and you divide by 2. So that's all you had to do for each of these. add them up, divide by 2. So like these two, when you add them up, is what, 34.8. Half of that is 17.4. So the midpoint here would have been 17.4. 17.4 is literally halfway between 15.2 and 19.6 because it's 2.2 above 15.2 and it's 2.2 below 19.6. So then on the second one, your midpoint would have been, let's see, this is gonna be 43.8, so that's gonna be 21.9. It's gonna be 21.9. 2.2 above and below. That's actually helpful, so, but, so let me keep writing these down for y'all, but let me give some space here. So that's 21.9. So you should have got 21.9 for the second midpoint. You should get 26.4 for the third midpoint. You should get, let's see, 30.9 for the fourth midpoint. Should get 35.4 for the fifth midpoint. And then, so 35.4 there. You should get 39.9 there. You should get 44.4 there. So those should have been your midpoints. Again, all of these, just add the two numbers and divide by 2. You might have also noticed after you got a couple of these, you might have noticed a pattern to what those midpoints were. And if you noticed that pattern and used it to get the others to kind of save yourself a little time, that's awesome. So do that. So if you can see those patterns, do that. But actually, again, I just want to give you guys a reliable way to always get the midpoint because that would only apply on a frequency table, that pattern that you figured out. So I'm not even going to talk about, we're not even going to I'm not going to teach any of that. So every time you need to find a midpoint, you just add the two numbers and divide by 2. And that's your reliable every single time, no matter what context, frequency table, finding, like I said, the mid-range or the mid-range. Anytime you need to find a midpoint in mathematics in any class, context, subject, you add the numbers and divide by 2. Add the two numbers and divide by 2. I still need to send those messages. All right, good. So now we're gonna try to find this mean. And so like I said, the reason we found the midpoints is, again, we don't know what these three numbers are, so we're gonna pretend these three numbers are 17.4. We're gonna pretend these 15 numbers are 21.9, and we're gonna pretend these 19 numbers are each 26.4, etc. So that's kind of what we're doing there. Is again, we don't know the exact data, but it'll be close enough, the exact data, to pretend that each of these is just the midpoint of those classes. So then how do we find the mean? So again, the mean means you add them all up and you divide by how many there are. Well, again, before we didn't know what the data is. Now we have a proxy for that data. We know that we have 3 17.4s, we have 15 21.9s, we have 19 of these, etc. So what you could do is literally write that all out. You could write 3 17.4s, 17.4, 17.4, 17.4, and then 15 21.9s. And you could literally go through and add them all up. Now, as you can probably think and see immediately, that would take a lot of writing and a lot of time. So we need a shortcut here. So it's not that we're still doing mean, we're still adding them all up. But if I know that I'm adding, for instance, 3 of these numbers up, there's a shortcut for adding those 3 numbers up. And so what's the shortcut for adding the same number over and over? Good, multiplication. So we literally can multiply, so we can do 3 times 17.4, and that'll give me all of, that'll give me all of the 17.4s added up. And I would have to add up 21.9 15 times separately if I actually listed this all out, and that's hella long, it takes way too much time. So my shortcut is I'm going to multiply 15 times 21.9. And I would have to, even worse, I'd have to add 19 26.4s, which just would take forever. So instead of that, I'm gonna, my shortcut, again, your shortcut for adding the same thing over and over again is multiplication. So I'm gonna multiply 19 times 26.4. So we can get all of these numbers added up for each class by doing multiplication. And then what we're gonna do is we're gonna add those all up and divide by how many there are. So we're still, like I said, we're still doing the mean. We're adding everything up and dividing by how many there are, but we're using multiplication as a shortcut because we've chosen for each class to pretend it's 3 of those numbers, 15 of those numbers, etc. So if you're adding the same thing over and over again, that's multiplication. So let's, as a class, let's kind of work this through. We get, so calculator going, let's make this. Yep. All right, so 3 17.4s. What do you get? What is 3 times 17.4? Or what is 17.4 added 3 times? So just have you guys follow along. I'm gonna ask you, do it on your calculator real quick and just kind of shout it at the screen. Good, so 3 17.4s is 52.2. What about 15 21.9? So what's 15 times 21.9? Oh, fuck, I need this to actually work. 21.9. Let's get the right number there. That is 328.5. So these 21.9s, those 15 of those, if you hand added all of those together, you'll get 328.5. Oh, no, that does make sense. Okay. And then we would have to add 19 26.4s, but instead we can just multiply. So what's 19 times 26.4? And I'm getting 422.4. And then we would have to add together 6 30.9s. So again, instead we can multiply. What is 6 times 30.9? That one actually I can do without a calculator. But since I already did it, you should get 185.4 out of that. And then we need to do 7 35.4. 7 times 35.4. And what do you get there? So get 247.8. And then we would be adding together 0 39.9. So all that means, all the 0 means is we didn't have any data in here, right? So there's no entry, there's no number. But what is, so if there's no number, the value is what? It's 0. And again, our little procedure echoes that. 0 times 39.9 is a 0. And then we would have 144.4. What is that? Good, that's 44.4. So all my numbers in this category would add up to this, all my numbers in this class would add up to this, etc., all the way down. So then all I gotta do is add all these together. So here we actually need to do some addition. So let's add all that together. Just again, once you get it, shout it at the screen. So what I'm getting is 1,280.7. So all 50 states in the District of Columbia, then we now know that they add up roughly to 1,280.7. Then again, so for a mean, we add them all up and then we divide by how many there are. Now, when I say divide by how many there are, I mean, like we did for the previous two problems, I mean, you divide by how many data points there are, right? So when you go to divide here, you're not going to divide by the number of classes. You're not dividing by 7. You're dividing by all of these added together. How many actual data points you have. Now, from reading the problem, you should actually know how many data points we have without needing to add these together. But if you're given a frequency table without much description up here, that's kind of what you would do is we know we have 3 data points in this class, 15 data points in this class, 19, etc. So we could add all these together and that would tell us the total number of data points. But again, from the problem, it says 50 states and 1 District of Columbia. So all of those are going to add together to give you 51. So my mean is going to be 1280.7 divided by 51. And so divide that and let's round it to the nearest 1 decimal place. Since all our data is kind of like that. 1280.7 divided by 51. What are you guys getting? So what I see is this is 25.1%. So the mean percentage of population over 25, 26 and up, that has 4 years of college or more, bachelor's or more, is 25.1%, about a quarter of adults over 25. So again, it's kind of not, the reason they did over 25, it's kind of not fair to do this, to collect this data or like make this analysis and assessment on people 25 and younger because they're still getting their bachelor's, right? So it's like, you know, we're trying to look at the end result, right? So once people have had time or the traditional time that most people get through to do that, do their bachelor's, you know, what's the output? What's the result? How many people end up getting their bachelor's? And like I said, so the mean here is 25.1%. So we can, so all of this to kind of get the mean. So like I said, there's 4 measures for central tendency: mean, midpoint, mode, and mean, midpoint, mode, and mid-range. Let's think about the midpoint. So could we do a midpoint for this data? So again, data given this way, rather than knowing each individual piece of data. What do you guys think? Good. So the midpoint, so like the mean, we were able to at least make an approximation by using the midpoints of these classes. But if you think about it, the midpoint overall for the data means you would have to list the data from least to greatest and find the middle piece, right? That's what we did for the 2 problems previous to this. Well, again, the problem here is I don't know each bit of data. And it's a bigger problem than we had with the mean, because again, there's no formula for finding the midpoint. You physically need to actually list all the data out, and we just don't have that, right? Now, one possible solution is, again, we could use the midpoints. We could basically do is pretend we have 3 17.4s, 15, 20. So just like we were doing for the mean, and you could write a list of 3 17.4s and then 15 21.9s and 19 26.4s, etc. And you could find a midpoint of that list. And so I've actually seen some other textbooks that I've taught out of, that's how they do this. So in other textbooks that I've taught out of, when they give you a frequency table, you actually do go find the midpoint. This textbook doesn't do that. So I say that to tell you guys that it is mathematically possible to do things that are not in these textbooks, right? And keep talking, I keep telling you guys or talking to you guys about how statistics is much more subjective than algebra, right? So I want to start out saying, can we find the midpoint? Oh, yes. You can write 3 17.4s and 15 21.9s and 19 of these, and you can list them out and you can find the middle. Or if it is gonna get very tiring to write all those numbers out. So you could, in some ways, in your mind, imagine essentially what the middle position should be, and then find that by kind of counting up using these frequencies. So you could do that. I think the reason this book doesn't have you guys find the midpoint is, I will say, the one problem with finding the midpoint using that method, using the midpoints of the classes, is that, you know, these three numbers that were from 15.2 to 19.6, they're likely near 17.4, but what if they're way below? So what if those numbers are 15.2, 15.3, and 15.4? Then treating those three numbers like they're 17.4 is gonna, it basically, as you go down through these classes, it's gonna progressively get farther away from what we're gonna call the midpoints of each class. It's gonna progressively get kind of farther away. So basically, it doesn't hew as close to the midpoints of the classes. The midpoint doesn't keep as close to the midpoints of the classes as this mean does. So I think this book doesn't do it because it's basically, it's a less accurate measurement. But you still can do it. It still gives you an approximation of the midpoint. And like I said, this textbook doesn't do it, but other textbooks do it. So it's still mathematically, it's something you can do. But because this textbook doesn't do it, I'm not gonna kind of take the time to go through it. Just so that I can just, not just to only prep you guys for what you're gonna see in the homework, but you know, so we have time to get to the rest of the stuff in the class. So they're not gonna have you find the midpoint on data like this. They think it's, you know, it's a little more inaccurate, or it's a little more far off from the real answer compared to maybe the mean. They will ask for the mode though. So the mode is which number happens the most. And again, we don't know the exact numbers, so again, the issue here is, well, how can they find a mode? We don't know which numbers are even the real data. And what do you guys think? So looking at this frequency table they've given you, why do you think that we can go ahead and find the mode here? Good, because frequency does kind of tell us what happens the most, right? So it doesn't tell us what number happens the most, but a frequency table tells us what class happens the most. And that's easy to see from the table. So the table essentially has already done the job for us. So they're gonna ask for, notice they say not find the mode, but the modal class. So they're gonna ask for which class happens the most. And again, you do not have to do a lick of calculation. You don't have to really do anything other than look at your table. Which class happens the most here? Good, 24.2 to 28.6. And I'm pretty sure, actually, I want to check. So some books would still ask you to give, or basically have you give the midpoint for that modal, as for the modal class, but no, this one just does the modal class. So good, that's our answer then. And then notice that it doesn't ask for the mid-range. Again, you could do the mid-range on something like this because we have a low, we have a high. But it's gonna be even more inaccurate than it normally is, because we don't really know that that last piece of data is at 46.6. And we don't even know that the first bit of data is at 15.2, even though that's, for the way we set up a frequency table, that is supposed to be what it is. The first bit of data is supposed to be sort of the low here. But we definitely don't know if that last bit of data is 46.6. That last bit of data, this one at the end, could be 42.2. If you find the midpoint of 15.2 and 42.2, that is actually going to be decently different than the midpoint of 15.2 and 46.6. That difference there is 4.4. So anyways, so the mid-range is usually pretty inaccurate. It's even more inaccurate here because we have no idea where this one that highest data point is. So they just won't do the mid-range. Which in my previous books I taught out of, they didn't do the mid-range either for a frequency table. So for this homework, if it's a frequency table, they're only going to ask you for the mean and modal class. Now, again, the question is, which one of these is the better, is the better measure of the middle? And looking at this frequency table, you have an idea of the distribution. So what's this distribution of data? And probably by now, hopefully almost, again, turn that on its side and almost turn it into a bar chart in your mind. You almost don't have to write it out. What would the distribution, the shape of this distribution be? Good, so you can kind of see we have our high bar here, but our high bar here is pretty far to, it would be the left, right? So we're gonna have a high bar, another bar that's pretty high, and then it kind of tails off, but it does kind of curve down. So it kind of curves down, it's a high bar, and then curves, tails back off. So that's gonna be a skewed right distribution. So which of these numbers then kind of hits the middle of that skewed right definition, or they call it a skewed right distribution better? And again, this is one of those things you could probably make arguments either way. There's a huge argument for the modal class because it is the tallest bar, right? There's 19 of them in there. So my true middle is somewhere between there. But notice that my mean is actually between there as well. And so it's just a question of whether my middle is a little closer to the 24.2 or a little closer to the 28.6. If you think it's a little closer to the 28.6 because there's a lot of these numbers, then you'd probably use the modal class as your average. But if you think it's a little closer to the 24.2 because there's also 15 of these, then you would probably use the mean as your average. And again, like I said, there's a good argument both ways. So either one of those is probably good. Both arguments are convincing, can be made. So, right. So we can now find at least mean and mode. Like I said, you could technically do the midpoint. I'm using the wrong word, a median. Guys, I'm really sorry. When I kept on saying midpoint, I really meant median. I was using the wrong word the whole time. So we can find the median, the middle point of all of this. You can technically find that using these midpoints. But you can find these for data that's given as a frequency table rather than actually seeing the data. Good. All right, then one last thing that they look at in this section, which you guys are actually familiar with, even though you've probably never heard the wording for it. So you guys are in this stats class that you've been in, maybe this is your first semester, but even if this is your first semester, you're in a bunch of other classes. And every class you take gives you a grade breakdown, right? So some percentage of your grade is the homework and some percentage of the grade is the test, etc. Like here, what is it? 20% of your grade is the homework. Basically, I think it's, how did I set this up? It's 60% of your grade is tests, and then another 20% is your final. What do you call it? So if you know that grade breakdown, then as you're going through the class, you can actually kind of calculate your overall grade. And maybe some of you guys are already doing that. And maybe you're not, but at least hopefully that makes a little sense to you of, okay, if I know 20% of my grade is this and 60% of my grade is this, then I can start calculating my average for the class. So notice that we call it an average. Your grade in the class, we call it an average. Called an average because it is what's called a weighted average. So the idea is a weighted average. So grades are the most prominent example of a weighted average that we actually deal with every day. It is an average. It is a true average. It's like basically like having a mean. It's like more like a mean than anything else, but is an average created by some sort of so they call it a weighted average because the weight means the percentages. So the 20% of your grade being the homework, that's the weight of that grade. So whatever the grade is on your homework, your average on your homework, you're gonna weight it. You're gonna by 20%, and whatever grade average you have on your test, you're gonna weight that by the 60%. The grade you get for the final, you're gonna weight that by the 20%. So let's actually do a problem. Well, yeah, let's do a problem with that. let's actually go calculate, basically what I'm saying is let's go calculate about your grade. And let's go calculate an actual grade using a grade breakdown, kind of these weights. But that's all the weighted average is, so let me get a visual for you guys. Let's look at 27. Erase. Yeah. So let's look at 27, but I'm gonna do the work. We actually have some white space to work with, so we'll do the work down here. So an instructor, so let's say you're in another class. And an instructor grades their tests, their exams 20%. The term paper is 30% of your grade, and the final exam is 50%. This is not a good way to do the class. So your final exam should not be 50% of your grade. But I digress. So in this class, in whatever class this is, 20% of your grade is your exams, 30% is your term paper, 50% is your final. So students, you have grades of 83, says 83, 72, and 90 respectively. So whenever you see that respectively, it basically just means the position of these is the same as the position of what you read before, right? So like in the previous sentence, it was exams, term paper, final exam. So they're saying respectively means 83 is the exams, 72 is the term paper, 90 is the final. And we want to find, they want you to find the student's final average, but not just they, you want to know what grade you're going to get in the class. So think about this. So I'm going to write a table out of this. You don't have to write this table, but I'm going to use this table to give you the idea of what we're doing. So I'm going to write the weights of each category, and I'm going to write the grades in each category. And the categories are the exams, term paper. I'll just write paper. And the final. So in some ways, you can think of these exams as your categories or your class, or sorry, like the exams, paper, and final as your categories or your classes. So it ends up that actually a grade distribution. So actually, well, let me say it in a couple after we make a couple more points. But we can think about exams, term paper, final. It seems like they're categories. It seems like they're classes for a frequency distribution. And we know that the weights, so exams are 20% of your grade, papers 30%, and the finals 50%. Now remember when we were doing the lecture, or the section on frequency tables, right at the end we were talking about a relative frequency table. What was the difference between a relative frequency table and a regular frequency table? Good. So a regular frequency table gives you hard numbers as a count, right? Like we just looked at on the last problem. Relative frequency table, relative in mathematics always means percentage. It gives you percentages as your count. Notice that we have percentages here. And then for this category exams, my average on my exams is an 83. And for this category, my term paper, I got a 72 on that term paper, and I got a 90 on the final. So a couple things to notice. This looks hella like a relative frequency table. Because it is. So your grade breakdown that you see in all these classes is actually just a relative frequency table. It's saying that 20% of your grade is exams and 30% of your grade is papers and 50% is finals. It's giving you a frequency in percentages. And then notice that these grades here look, this column looks a bit like the midpoint column that I had on that last diagram. And I will say they're not midpoints, but it kind of looks like that. Because what I'm saying here is basically I'm saying 20% of my grade is an 83, and I'm saying 30% of my grade is a 72, and I'm saying 50% is a 90. So, 20 out of 100, of that class is an 83, 30 out of 100 is 72, 50 out of 100 is a 90. So just like that last example, so on that last example, I multiplied the frequencies by that midpoint, or kind of that number that represented what each of those data points were. Just like that, all you have to do to get your grade here is you're going to multiply 20% times 83. And you're going to do 30% times 72. And you're going to do 50% times 90. And that'll give you portion of your grade from the exams, the amount of portion of your grade from the paper, portion of grade from the final. Then you're just going to add them all up, and voila, you have your grade. You have a weighted mean or a weighted average. So the grades that you do in every class is a weighted mean. That's the weights are your percentages, but like I said, those are just your relative frequencies. So you multiply each of those by the grade in each category, each class. Then the only difference between this and what we did on the last table is you're not going to then, once you add them up, you're not going to divide by how many there are, because my frequency is not a number, my frequency is percentages. So as long as these percentages add up to 100%, then you don't have to divide by anything, because once you add these results up, that's your grade. That's 100% of your grade. I don't know if that made sense, but because these are relative frequencies, because these are percentages, we don't have to divide by how many there are, because basically in some sense, you've already divided. So remember, 20% means 20 over 100. That means 30 over 100. So we've already sort of divided by 100. So in some sense, we've already divided by how many there are, if that makes sense. So hopefully maybe that connects for you. But all we got to do is 20% times 83. And so I'll have you do that really quick, as we'll just do this as a class as we're doing this work. What is 20% of 83? So when you're multiplying, move your decimal twice to the left. So that's actually really 0.2. You're doing 0.2 times 83, or just throw this in your calculator. But 20% of 83 is 16.6. And what is 30% of 72? Just give you a second to do that. That is going to be 21.6. And then what is 50% of 90? Or what is half of 90? Good. That's 45. 45.0, just 45. It's really just 45. And then I'm just going to add these up. That's my grade. So what is 16.6 plus 21.6 plus 45? What I'm getting is an 83.2. Your grade out of the class is an 83. And that's not just for this problem, but so in any class that you're ever in, if you at least know your grade in all the categories for the class, for the little grade breakdown that they give you, you can always calculate your grade. So by the end of the semester, you can calculate your grade before you even look at Canvas, as long as you know kind of your averages for each category of grade. All right. So I think I'm gonna leave off with that. So that's kind of perfect. That gets you not only everything you need for the homework, but that gets us everything we need for in terms of mean, median, mode, and mid-range. Good stuff. So I will see you guys. That's part 3 of measures of central tendency, and that's all of it. So I will see you guys for the next section, 3.2, next time.